Hey guys, now I'm going to explain you about the basic topologies that are existing in this data communication networks, data cable communication networks. Coming to the topologies, there are only four topologies that we're going to discuss. First thing is mesh, star, bus, and ring. I'll explain you everything in detail. No need to worry at all. Uh, Coming to the first thing, it is about mesh topology. Here, if you take in a mesh topology, every device has a dedicated point-to-point link to every other device. That the term dedicated means that here see basically here see if here total 5 stations were there and each station is connected to every other station. See from this station, let us suppose this is S1, S2, S3, S4 and S5. See from S1 it is having to S2, S3, S4, S5. Similarly from this S2 to S1, S3, S4, S5. Likewise, for every station, it is connected to another station. That is called point-to-point link. And here, the term dedicated means that that link carries traffic only between these two devices. No other device gets involved in it when these are in the connection. So, the number of physical links that are present here is here. Let us suppose n nodes were there, and let us suppose that each node must be connected to every other node. That means that it must be connected to n minus 1 nodes. So if you take this node 1, it must be connected to n minus 1 other nodes. Similarly every node should be there. If here we are taking n number of nodes, then n into n minus 1 number of physical links are required. But if each physical link allows the communication in both the directions, that means in duplex, that means two physical links are not needed. Only one physical link can do the working of two physical links, so that the physical number of physical links will become in duplex mode, number of physical links will become n into n minus 1 by 2. This is about the mesh topology. And coming to the advantages, no other no traffic will be there, because only the data is carried from each one station to other station. No other station is involved. And also it is robust. If any of the connection fails, remaining connections will be in the working condition. Only the faulted thing will stop, or so it is robust. Coming to the disadvantages, many cables are required. The amount of cabling is very more. And next thing, wiring can be greater than the available space. That means the space complexity or the available space will not be sufficient for this thing. And coming to the star topology, is nothing but one hub will be there. I'll explain you very simply. One hub is there, and all the stations are connected to the hub, and whatever that data, whatever it is gonna be communicated, that communicated data is gonna go to the hub, and this acts as a central you know it acts as a central controller. It is called as a hub. It acts as a central controller, and it sends the data to the destination address, destination station, whatever, to where it wants to be delivered. So here 4 stations are there, and that many advantages are there for the star, because one central controller will be there. And it includes robustness, because if one link fails, only that link gets affected, not all other links will remains active. And one most big disadvantage of this star topology is that everything depends on a single point, that is the hub. And if the hub goes down, the whole system is dead, right? Only if any of the link fails, that only that link will, if this link fails, only this will be affected, every other thing works. But if the whole central thing, or all this central controller hub, that is the hub, goes down, the whole system will go dead, because every thing is connected to the hub only. That is the only disadvantage that the star topology possesses. And coming to the bus topology, here we'll have two cable ends, and let's it can be compared to the electricity, like how electricity is compared. how electricity is sent to every house, one basic line will be there, right? That is this line. This is known as backbone. And similar, see here, like similarly, how lines exist. Like there is no need of establishing the transformer or line everywhere, right? So similarly, that line is considered as this, that is the backbone, and every station is connected to the line, and the connecting place is called draw tap, and the connection to this line, this intersection point is called drop line. This line, this is bus topology. Whenever you want to communicate some data, the data is sent through this backbone, and whatever station requires the data, it drops it here, and whatever is going to take it, it takes it. This is also a point to point connection. This is the bus topology. And coming to the ring topology, last but not least, here, see, here every station is connected in a ring shape. That means in a ring connection. Every station will have two devices on either side of it. That is, if you take this station, it has this and this, and if it's gonna, if this is S1, S2, S3, S4, S5. If some, this S1 is going to communicate, wants to communicate with this S5, then it sends the data to the repeater, and the repeater checks whether the destination address is S5 or not. It is S1, so it goes to S2. Here S2 is not S5, so again it goes here. It is not the destination address. It comes back and it goes to S3, and it goes to S3 and it checks. As it is also not S5, it comes back and the repeater sends it to the next repeater. Likewise, it is done till it reaches the S5, and if it reaches this destination address, then it is received. So this is how the ring topology works, and these are all the topologies that are present here.